3.4 measures of position and outliers. So, what is the z-score? So, simply put, defining it without defining it mathematically, a z-score is just a measure of dispersion for a single data point. It measures how far the data point is from the mean. More specifically, it measures how far a single data point is from the mean and forms the standard deviation. So say I'm 5 feet away from you. I could be 5 feet away from you, or I could be 5 rulers away from you. I could be 60 inches away from you. So specifically, it's the distance it forms the standard deviations, and we'll get to why that's important in a second. But let's talk about how we calculate it. So first, for population and sample, it's basically the same formula, except that you're going to be using the population mean and the sample standard deviation. And yeah, the formula is the exact same though. You just use the sample mean and population deviation. Um, so the actual formulas are right here, where it's forgot what this letter is, but I think it's like new or something. I'm not sure. Um, but that's how you calculate it, and it's important that we measure it in forms of standard deviations, because standard deviations is how dispersed the data set is. So the higher away that you are in forms of dispersion, meaning that the further you are, and the further standard deviations you are further away from the data set. If we simply measure distance, but the standard deviation is extremely high and we don't divide it, so we simply just measure the distance, we can't actually tell if that's a high dispersion, because what if the standard deviation is also high? That means all other data points are dispersed and you're not that much different from your peers or your other data points. So let's say I'm like 6 feet tall, and let's say the mean is 5 feet. Um, Although I seem like a whole foot away from 5 feet, um, if the standard deviation is like super high, like 5, then plugging in the formula we get 1 over 5, um, which means I'm not that many standard deviations away. I'm I'm pretty close to the actual um, data point in terms of a z-score. So this is typically useful for comparing points, 2 points in two different data sets, and to see which disperses more from the standard deviation, or from the mean. Sorry. So this is the scale. If z is greater than 0, that means that the point is higher than the mean, which simply means that it's higher than the mean and is dispersed further away from the mean. If it's 0, that means it's exactly equivalent to the mean, because in the formula it would just be mean minus mean, which equals 0. And if z is less than 0, it's below average and it's lower. Um, and um, yeah, that's how it is. So recall that the median separates the bottom 50% of a data from the top 50%. And it's also important to note that these are not absolute value brackets. I only put them to show that you can't be negative standard deviations away. But it's important to note that the z-score can actually be negative, which simply means you're below the mean in forms of dispersion. So recall that the median separates the bottom 50% of a data set from the top 50%. The kth percentile, which is just a percentile denoted pk of a set of data, is a value such that k% of the observations are less than or equal to the value. So this seems complicated, but all that means is if you're on a certain percentile, all the data below is k% of the data. For example, let's take a girl named Hannah, and she scored in the 74th percentile. That means 26% of students scored better, or 74% scored worse or equal. So as you can see here, Hannah is in the kth percentile in terms of the test, meaning that 74% of data is less or equal to the value. Quartile 1 is the first 25% of the data set. Quartile 2 is the 50th percentile, and quartile 3 is the 75th percentile. And we'll talk about errors later, but how do we find them? First, we sort the data from lowest to highest, and And then we find the median, which is just going to be the middle point. If the median is 2 points, you just find the average of them two. Then you find the midpoint of the lower half and the midpoint of the higher half. Note that the midpoint is not position based. It is position based when you're trying to find it, but the values are not position based, meaning that if your midpoint is 5, then your quartile 1 isn't going to be 2.5. That's not how it works. The midpoint is going to be the 25th or 1/4, the number at 1/4 of the data set, which can be anything from 1 to 5. And that's why you get skewed left and skewed right. And we'll get into that a little bit later. But the interquartile range is measuring spread without outliers. So all that is just using the third quartile and the first quartile. You just subtract the first quartile from the third quartile, and this is going to be the range of the middle 50% of the data. So that would be the median, which is the exact middle, plus 25 or minus 25% of the data. So it's important to note that these percentages are simply percent of the data, not percent of the value. So if the middle point is 5, this doesn't mean that the median is 7.5 and 2.5. Or it doesn't mean that it's, if it's 10, then it doesn't mean it's 12.5 and 7.5. It's about the data points. It's about the frequency. So if there's 10 data points, or 11 data points, let's just say for simplicity, it would be 2 or 3 above and 3 below, because that would be 25% of the data set. So the lower fence is just the Q1 minus 1.5 IQR, and upper fence equals Q3 plus 1.5 IQR. Any value outside the fences is an outlier, and that's how you determine it when we're talking about median. Because all that these percentiles are a measure of median, not mean or mode. So any value outside the fences is an outlier. So here's how to detect outliers using quartiles. First, you find the first and third quartile, subtract them to calculate the interquartile range, calculate the fences, which is lower fence equals 1.5, or lower fence is equal to Q1 minus 1.5 interquartile range, and the upper fence is third quartile plus 1.5 interquartile range. So any values outside the fences are an outlier. So when do we use what? So note that all forms of dispersion are based off what measure of central tendency we use. So when we're measuring standard deviation, we use the mean to calculate that, and therefore this measure of central tendency would be the mean. For skewed graphs, it's typically better to use median, and that's why we use interquartile ranges as a spread measure. Yeah, the interquartile measure is the form of dispersion here. And yeah, that's it. So